Hello everyone, today we'll talk about a solution to the problem maximum number of fish in a grid. We see grid in the title of this problem and we know that, well, a grid problem will probably be solved using a simple traversal over a grid, and indeed it's the case here. This is essentially just the problem of finding all the islands. Plot twist here, the islands are not land but water because we're a fisherman swimming on water, but still we want to visit all the islands and we want to add up the numbers on an island. This is the score for the island, and we want to return the island with the best score. Let's jump into the code, which is very standard. We have our directions, so change in row, change in column, and pairs of changes. Height and width of the grid, and the best solution found so far, which we're going to return at the end. And now for every possible starting position for an island, we haven't visited it, so we go through all the rows, we go through all the columns. We haven't visited that island if there is a place where we have some fish. So if grid is 0, we continue. Otherwise, here's a new island, so we want to visit all the nodes on that island and sum up their values and update best at the end. So we start with the value from that water cell. We have to remember, of course, to set it to 0 because this is essentially our visited array, just sinking or removing all the fish and making it essentially a land tile. And here we're going to be doing a DFS, so we're just going to be using a simple stack, a simple list. We start with row and column, and while there is something on the stack, we take it off the top of the stack, and for every possible direction, so for change in row, change in column, we get the new row and new column. If they are out of bounds, we continue. If they are a cell that was either visited or is a land cell, so again, if this grid is 0, we continue. Otherwise, we get all the fish, set the value to 0, and add it back to the stack. At the end, while we have run out of elements on the stack, we update best, and of course at the end we return best. Very standard grid problem.